A very good morning to my dear doctor. I am Karishmara Subramaniam with my matrix number CN240098. We are from Group 3, would like to present about petrochemical industry, and the chosen company was Malicino Chemical Industries.
Assalamu alaikum, I'm Noen, and I will start talking about the petrochemical industry. Petrochemical industry is industry used to convert oil and gas into useful products like like solvent and plastic, but it causes pollution and it uses a lot of energy. We chose Milasino Chemical, which is a Malaysian company that make solvent and plastic, use it in many other industries. So in this project, we will look at how they are making their products and how they are trying to use eco-friendly methods and the challenges and benefits of being green chemistry. So Milasino Chemical, what they make. As I mentioned, Milasino Chemical produce important materials like ethylene, propylene, and plastic. They are used to make many things we use every day, like packaging and clothes. What they use oil and gas as raw material to create their products, but this take a lot of energy. Where they supply their products to many industries in South Asia. About the industry, petrochemical are used to make everyday items such as bag and bottles. They are important in our daily lives. Making this product is take a lot of oil and gas that causes pollution and harms the environment. Medicinal chemical is important for making this product, but they are needed to make their work better for the environment. This is where the eco-friendly methods come in. So here in this slide, we will talk about the green chemistry. Green chemistry focus on reducing pollution by using eco-friendly method in the petrochemical industry. It's about creating products in the way that it's better for the environment and the human lives. So while green chemistry faced increasing demand, more people and companies around the world want to use eco-friendly method for everyday products. This has pushed the industries to adopt greener practice to stay competitive. Next, regularity pressure. Countries like Malaysia has set renewable energy and goals. This encourage industries to reduce their environment's impact and meet new standards. Last, economic benefit using green chemistry, reduce waste, save raw material, and improve energy efficiency. This low cost and increase profits and in the long term. So that's all for me. Now I will give you to the next presenter. Thank you.
Hi, my name is Muhammad Rizal Arif. My matric number is CN240109. So now I will be presenting about the impact of green route process towards environment, humans and sustainability. So for the first impact towards environment is the reduction of carbon emission, which is the green route process aims to reduce carbon emission, contributing to global warming by implementing the energy efficient technologies, renewable energy source and also carbon capture methods. For instance, in sectors like petrochemicals, bio-based feedstock and carbon capture and storage system can significantly reduce emission, demonstrating the potential of these strategies in reducing environmental impact. The next is the waste reduction and pollution control, which is green process aims to reduce the waste generation and promote recycling, reducing landfill environmental impact and pollution. And also the traditional industrial processes produce a large amount of waste, including hazardous chemical. So the green process using the green catalyst and efficient processes can reduce the waste output, the resource requirement, and also limit the pollution by reuse the waste heat for energy production. So next is the impact of green route process towards human, which is first is green route process can improve quality life due to it can enhance quality of life by creating a cleaner environment, safer working condition and healthier communities. It reduces pollution and waste, while sustainable practice in agriculture, manufacturing and construction ensure access to healthier food, clean water and better air quality. And other than that is job opportunity, because green process frequently call for infrastructure, innovation and new technologies. This creates a new employment prospect in fields including such as waste management, sustainable agriculture, renewable energy and the development of green technologies. Furthermore, green industry can save money over the long run by encouraging more sustainable and efficient production, which will make them profitable and spur a long-term economic growth. For the last part, which is the sustainability, there are three types of sustainability, which is environmental, social, and economic. So first is environmental sustainability. By reducing resource consumption, emission, and waste, green process contribute to the long term of health of ecosystem and the planet. This ensures that natural resources are available for future generations and that the ecosystem remain viable. For social sustainability, green process enhance social sustainability by creating a safer, healthier environment, improving public health, and promoting social equity by ensuring all communities benefit from cleaner industries and practice. The last part is economic sustainability, which is green technologies promote economic sustainability by reducing costs, increasing efficiency, and driving innovation. Renewable energy, despite initial investment, reduce reliance on fossil fuels and minimize energy costs. Green industries stimulate new markets and create a new job opportunities, contributing to a more resilient economy.
Good morning, everyone. Today, I explain the processes involved in petrochemical production, which is divided into upstream, midstream, and downstream processes. Let's begin with the upstream stage. The first step is desalination, where salts are removed from crude oil. This is crucial to prevent corrosion of refinery equipment. Once the crude oil is desalinated, it goes to crude oil distillation, also known as atmospheric distillation. In this process, the crude oil is separated into different fractions based on boiling point. These fractions are essential for further processing in downstream units. Moving on to the midstream stage. The main step here is vacuum distillation. This process deals with the residue from atmospheric distillation. Instead of subjecting it to high temperature, which might cause cracking, it is distilled under vacuum. This lowers the boiling point and allows for the separation of heavier fractions into more useful components. Now, let's focus on the downstream processes, which refine the fraction into valuable product. The first downstream process is the naphtha hydrotreater, which removes impurities like sulfur, nitrogen, and oxygen from naphtha. This treated naphtha is then sent to the catalytic reformer, where it is converted into reformats, a high-octane product which in aromatics. Reformat is a key component in producing high-quality and petrochemical like PET. The next step in downstream process is distillate hydrotreater, which removes impurities from distillates like diesel to meet fuel quality standards. After this fluid catalytic cracker, which is FCC, takes heavier fraction and breaks them into lighter, more valuable products such as gasoline. Another important process is the Maroc unit, which desulfurizes lighter products like LPG and jet fuel to make them environmentally friendly. Similarly to the hydrocracker uses hydrogen to break down heavier oils from vacuum distillation unit, converting them into lighter, lower viscosity products. Two final key processes are alkylation and coking. In alkylation, smaller hydrocarbons are combined into larger, high-octane components used for gasoline blending. Lastly, coking is used to break down very heavy residual oils into lighter fraction like gasoline and diesel. This process leaves behind petroleum coke as a byproduct, which can be used in industrial application. To conclude, the petrochemical production process is a highly integrated and efficient system, from removing impurities in crude oil to breakdown and reforming fractions into high-quality fuels and petrochemicals. Each stage plays a vital role in meeting global energy and material demands.
Thank you, previous presenter. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, I be to madam and beloved friends. Okay, my name is Muhammad Adil Sabri and my matrix number is CN240482. Now, I will continue about the advantages and disadvantages of the conventional of and green Europe process. Yeah, this slide I will focus to conventional, but the next slide I will focus to green Europe process. Yeah, now I will start with conventional. I have listed this down 2 advantages and 3 disadvantages of conventional. The first advantages is high scalability and efficiency. It is because the conventional process has been optimized over decades for mass production, allowing for large-scale manufacturing with output risk and cost efficiency. Okay, the second advantages is established infrastructure and market demand. It is because the infrastructure for conventional chemical processes such as factories, distribution networks and supply chains is already in place, supporting steady production and meeting existing market needs. Okay, next we focus to disadvantages based on conventional. Okay, the first disadvantages is high greenhouse gas emission. It's because many of conventional processes rely on fossil fuels, which release large amount of carbon dioxide, CO2 and other greenhouse gases during the production, contributing to climate change. Okay, the second disadvantages is the reliance on non-renewable sources. These processes typically depend on finite resources like crude oil, natural gas and minerals, making them unsustainable in the long term. Lastly, generate toxic byproducts such as carbon dioxide and sulfur dioxide. It's because conventional methods often produce harmful byproducts such as sulfur dioxide, which contributes to acid rain, and carbon dioxide which contributes to the global warming. Next is the advantages and disadvantages based on green chemistry processes. Okay, the first advantages is utilize renewable feedstocks like biomass. It is because green chemistry focuses on renewable materials such as plant-based biomass instead of finite fossil resources, promoting sustainability. Other than that, reduces carbon footprint also one of the advantages. It is because by leveraging energy efficient technologies and renewable resources, green processes lower the overall greenhouse gas emissions associated with chemical production. Last but not least, promotes waste reduction through circular economy practices. These methods are designed to minimize waste by reusing and recycling materials, aligning with circular economy principles to maximize resource efficiency. Next, we move to disadvantages. Okay, the first disadvantages is higher initial investment for technology and feedstocks. Okay, it is because implementing green chemistry often requires significant upfront costs for new technologies, infrastructure, and sustainable feedstock sourcing. Okay, last but not least, feedstock availability may vary seasonally. Renewable feedstocks like biomass are subject to agricultural conditions such as seasonal availability and weather factors, constantly disrupting supply chains.
Now, I would like to focus on issues in conventional chemical processes. Conventional chemical processes come with several challenges that have a significant impact on the environment and resource sustainability. A major concern is environmental pollution, as these processes often release large amounts of harmful substances. Greenhouse gases like carbon dioxide and methane contribute to global warming, while toxic chemicals such as sulfur dioxide and nitrogen oxide cause air pollution and acid rain. Another issue is the heavy reliance on non-renewable resources such as petroleum, natural gas, and coal. These resources are being depleted rapidly, creating long-term concerns about their availability and the need for alternative solutions. High energy consumption is another critical issue, as many conventional processes require extreme temperatures and pressures, demanding large amounts of energy. This energy is often sourced from fossil fuels, which further increases carbon emissions and environmental impact. Additionally, these processes generate hazardous byproducts including heavy metals, acidic waste, and organic pollutants. These byproducts require careful treatment and disposal, adding to operational cost and posing risk to human health and ecosystems. Addressing these issues is essential to reduce environmental damage, conserve resources, and create more sustainable chemical processes. Thank you. Now, let's discuss about health risks. Workers in chemical plants are exposed to toxic chemicals that can cause serious health problems, from respiratory disease to skin disorders. Additionally, communities living near plants faces risk from leaks or accidental release. It's crucial to implement robust safety measures, improve equipment, and adopt safer chemicals to protect both workers and public. Finally, let's address process safety hazards. Handling flammable substances and operating under high pressure conditions elevate the risk of accidents such as explosions or leaks. Equipment failures or human errors can have catastrophic consequences. By adopting automated systems, enhancing worker training, and conducting regular maintenance, we can minimize these risks and ensure safer operations.